Okay, Cup. Good afternoon. Welcome to your very first class in data analytics. This course will take place as Tuesday afternoon, as you're here. This course, funny enough, used to be called Big Data Analytics. Big data was quite kind of like a term that was very popular 4 or 5 years ago, but it's kind of like since gone away because actually all data is big now, so there's no point calling big data. Anyway, so first let's briefly run through the syllabus. Like I said in a pre-class comment, when I was a student, I rarely ever look at the class syllabus, but it's a good idea. It's a good idea, okay? So let's briefly run through. You should have this in the line group, but it's a good idea to go over them. So this is your autumn 2024. Right. So what does it say? It introduces students to the principle and practices of data analytics. Now, it's a suite. What's data analytics? Analytics are tools, okay? So analysis is the subject, is the activity, it's called analysis, or you analyze. But the tools that you analyze them with, they call analytics. And analytics doesn't usually mean one tool, it means a whole suite of tools. It's like, I don't know if you've seen those old-time Western movies where you have a doctor take a home visit, comes with a bag, and then they open it and have all kind of stuff. Well, it's a bag of tools of the trade for data scientists, so to speak, okay? So data analytics is sort of like a toolkit, okay, for data scientists. And, well, it's, these two are there for a purpose. They're supposed to mine a body of data for some end, usually business, entrepreneurial, business innovation, maybe a lot of times you see it's just simple marketing, just trying to make the best out of a client base you've got and so forth. And you see that it also mine information about how happy your employee is. So it's not just limited to marketing as you may have the impression of. Well, the idea is you mine data for information, and then you transform information into insights, okay? And based on that insight, you make better decision. It's kind of like an optimizing with a better knowledge. So the more you know about how the reality of your business or socio-economic situation or the problem that you face, the better you can solve it, okay? The better you can solve it. And hopefully in line with project-based learning, this would culminate in your class in some kind of term project. Now, the term project in a lot of class you have here at Batsai would finish with maybe some kind of video presentation or presentation deck. What I would like you to actually end up with and start having a practice, maybe a first go at it, is what's called a white paper, a technical white paper. A white paper is like an academic paper, except it's not as comprehensive. It doesn't have literature survey. It doesn't have necessarily new methodology, right? With academic paper, you're supposed to like bring new thing to the frontier of knowledge. But with a research project, with a term project, it could be, well, this is a well-known technique, this is a well-known problem. I want to see how to use them together as a practice. So you describe the methodology, the step you go through, the motivation, but it doesn't exactly add to the new frontier, it doesn't add new element to the frontier of knowledge. So you don't necessarily publish in a journal, right? Now, a lot of time you will see this as part as a media package for innovative product. So let's say your innovative product is an AI-driven tool that does something that requires sort of like special sauce. It's kind of your methodology, right? Well, that methodology, the part that is not secretive, the part that you can reveal, has to convince as well your client. because your client's going to pay you millions of whatever, dollars or baht for your software, has to believe that the methodology is sound, right? So it's not good enough to say, well, I use this technique based on well-known paper, okay? So sometimes you have to actually describe the methodology in detail, right? That, okay, this is how your software works, blah, blah, blah. So you write this white paper, okay? And you make it part of your media package so that when you, maybe you pitch a sales of this product to your client with a presentation, but your client also has a technical team, right? They're no dummies, right? Or even their own IT department has to take on this project and implement it seamlessly in their data infrastructure. There's some details about data format, whatnot. This is what the white paper is for, okay? So it seems like an academic exercise, but believe you me, in a very, especially in a corporate, I'm from a corporate background, you would not buy anything that just has a presentation deck. That is not believable, right? Okay, so hopefully we'll do that, and of course maybe we'll do video presentation because you guys are very good at it, and I think you guys enjoy doing it. Now, the idea is what? The idea is you have to have solid, and you're not the guy pushing the frontier of AI research or machine learning or probabilistic modeling, right? But you need to know how things work under the hood, right? So you're not learning how to drive a car and know nothing about how the car works, but you sort of like a very competent racing driver who, as you drive, notice different behavior of the car and is able to pinpoint that, okay, this seems like the spring is overly stiff or is underdamped or something like that, or maybe the geometry is wrong, or maybe the engine map is off. So you should know, like, under the hood how the car works. And then you and the race engineer can optimize it, okay? I don't know if you know this, but like, especially like in Formula One, but the car is not optimized once and that's it, like the car you bought, but it's optimized for a racetrack. And it's not just optimized for a racetrack, it's optimized for the racetrack and the condition of that day, okay? So anything from the temperature, the dampness, the wind, the crosswind, all kind of stuff enters into calculation, and you do all kind of tweaks and stuff. And again, go back to Formula One analogy. You have things like Friday practice, where driver goes in and actually give a very precise feedback in the language of engineers. That's the spirit of, in fact, that's the spirit of Basai education. You're not making the tools, but you're making the best use of the tools, and you can only do that if you understand how the tools work. Okay, so this superficial thing where, well, I'm just going to have a chatbot, or I'll have this AI that just recognize object, and that's that something like that's for high school students. Okay, so you're more at that, right? Okay, so this is a bit more detailed than we need, but what I like to do is sort of like the learning outcome is you should have, by the end of the semester, the experience of being able to put yourself in the shoes of a professional data analyst. Okay, you may not have all the tools, you may have not have all the skills, but you would be put in yourself in the mindset of, well, how would data scientists or quantitative analysts look at the problem and start to strategize way to solve it. Okay, the problem is to, I don't know, uplift your sales figure or address a new market cohort that the company hasn't gone into before, a new sector. How would you deal with this problem? What data would you need to do? What is the critical piece of information you need to know? And that critical piece of information, is it something that's embedded in I don't know, public data? Or is it something that is requires like a primary source or something like that. So all kind of stuff. These are what professional data scientists do. Okay? And I myself, I'm not, well, I guess professionally, I'm a data scientist, but I didn't start out purely as a data scientist. In fact, there was no such thing. I did my Ph.D. in computational intelligence, which is kind of like combination of artificial intelligence, machine learning, evolution, optimization, and all kind of stuff. But I started my career with the central bank. So in fact, I barely touched any of the AI stuff at that time. I was doing a lot of quantitative models. Certainly, my whole career is applied math, but start out with central banking, so looking at the credit risk model, how do you evaluate whether or not the banking system is strong or weak. So I use some kind of network graph theory for that. Then I as a first senior vice president of quantitative models and enterprise analytics at a commercial bank, SCB, I then focus on a more micro model, like pricing, FX derivatives, estimating or predicting default, or estimating default probability for a type of loan, a class of loans. It's more micro focus, but it's still applied math. And it was in a way calibrated against data. But throughout my career, I can tell you that we didn't have this mindset where the data is your resource and let the data start with the data and see what you can make of it. I was a little bit more objectively driven. Say, I want to learn about this. I want to know about this. What does the literature say? What is the model that describes credit risk? And then you go and say, okay, to describe credit risk, you need this model. This model has to be calibrated from real data. Okay, let's go to financial market, get some data and to do this. See? But what I like to tell you is that toward the latter end of my career, and in fact, where you guys are, it's kind of like the other way around. It's like saying, hey, I've got this data. What can we make of it? Okay, and this is something that I try to convince people at a commercial bank I was working for, but it was a little bit hard to convince them because the transition require a lot of different thinking. So instead of a sales team say, I want to increase credit card usage, okay, and then please give me a model and collect whatever data you need. The flip side is, hey, we are a bank. We interact with our clients. We have all kinds of information about our clients, right? The data about this. How can then we gain some insight from it? And once you get the insight from it, you go to the business planner and say, make a business model that makes money from this, right? So it's not like, I want to increase this sector usage of credit card. How do we do that? It's more like, I've got a wealth of user experience in the credit Visa card space, let's say a credit card space. This is the insight we found. From that, you formulate your campaign strategy to take advantage of that relationship. Okay? So this kind of like a preamble talk. I want you to get to the, maybe in the future, I wouldn't have to even say this because it will become obvious. It will be like in the new future generation, you never start with any kind of question. You start with data as an asset and just kind of like do a lot of algorithm to find pattern and see what come up, okay? But anyway, at least in my generation and still right now, the world is a transition, okay? But right now, at least, you're in an operating environment whereby the concept that data is first, the asset, the data is the asset. The most important thing is the asset is the data. And everything is downstream from there because mathematics becomes more you will see from the use of Mathematica. Mathematics is a lot more accessible than previous generation, even when you were in high school. Some of the mathematics things that require mathematics to do, you would have thought an obstacle because maybe you're not that great in math or you're not that thorough in your mathematical analysis. Now you have tools that helps you with mathematics. Okay, it doesn't take away the mathematics. It does rigorous mathematics, but it sort of like prevents you from doing stupid mistakes. Okay, something like that. So Mathematica, we'll talk about Mathematica later and why I chose that for this class. You're going to be doing some coding, although the way I see it, not all of you are necessarily going to be in the data science space as a professional. So some of you will be, let's say you're working toward your concentration in sustainability, smart city track, or health and well-being, right? So in that case, you might jumpstart the project by taking some data that you've got in your domain and do a little bit of Mathematica proof of concept, which you will learn literally how to do it throughout this class. And then say, okay, I'll take this data, I do some machine learning, or maybe I do this graph, I do some visualization. Hey, it looks like a viable thing, okay? And then you start to build your research and development team. But ultimately, when you go to, let's say, industrial strength software, you won't be using Mathematica. You'll be using, I don't know, Java, C++, C, Python, some of the newer language that's becoming maybe one day replace Python, but maybe not, okay? A lot of time in your generation, Python will be the go-to implementation tools, okay? But Python does have a little bit of it sits at a lower level of language than Mathematica. So you have to tell it a lot more. Mathematica is a little bit more like, I would like this thing done, okay? As opposed to do this, do that, do that, do that, okay? So a lot of things can be kind of encapsulated at a very high level. You see when it works. Right. So today is a listening day, so don't have to do anything. Just pay attention and maybe just look at my hands. So now I use my hand to describe stuff. So the concept of data analytics is going to be the foundation of everything we do for the rest of the term. Next week is introduction to Wolfram Mathematica. Basically, I'll give you what's called language primitives. So basically the basic grammars, the hello, how are you of language. You will see that class here, okay? A previous class was a bit of slightly disorganized because I didn't have the textbook finished, but now I finished the textbook, so the organization just follow almost linearly the textbook. So the textbook has 7 chapters, so basically just chapter 1, chapter 2, and so forth. So the chapter on, let's say, probabilistic modeling is 2 classes. Chapters on unsupervised machine learning is another 2 classes, and so forth, right? And I personally do not mind idea of term project being a group project. But if the class is not that big, I would prefer individual project. Okay, you learn a lot more. Okay, it takes a bit more of my and Dimutu, by the way, is your TA. It's very nice and popular among students. It takes more work on our part to evaluate and feedback on individual term project. So if the class is big, I'm not going to be able to do that. But I think we can manage. Okay, look at the size, just at the limit. Having said that, group project is also more fun because the project can be bigger, can be more challenging, and you can specialize within yourself. Like this guy's good on coding, this guy's good on finding new technology and the mathematics and understanding the paper and implementing techniques and so forth. So you can specialize among yourself. So group project to be honest, if you are all eager to contribute, you can actually learn quite a bit. We'll see. I haven't made the decision, but by default, if the class is not big, we'll make it individual project. Right. So this thing it's not in the textbook, but it's good to have a little bit of wherewithal about where you sit. So it's not about data science and data analytics only, but hey, with the world of large language model, AI automation, maybe some of you may have heard of agentic workflow, where you sort of like have an AI as sort of like a co-pilot, but sort of like help resource different tools. Then where do we fit? Now, how does this fit? How is AI going to change us? How can we be a meaningful contribution when the world seems to now just go to AI for some answer, right? So maybe that lecture, but that's completely optional. What we might do is have another workshop, because sometimes students prefer to have a lot of workshop. We'll see. So this is meant as my plan, but we'll see. Okay. By the way, as with Basai education, you get more the more you put in. Okay, you get more the more you put in. I think of Basai or Basai as a platform rather than as a feeder. So you're not just sitting there and then I just feed stuff at you. Okay, it's more like it's a bit more interactive. So certainly I give you something, but if you bring in something and you raise it, it might be even something I don't even know. I might have to do some homework for it, and then we can come back and the content itself can expand. For example, and I'm not suggesting this, but let's say there's no elements about mechanical or robotic system in this. But if you really are keen on saying, hey, how does data science help calibrate a robotic project or something like that? Let's say some guy comes in, okay, then bring it up. Then I might have to sort of like introduce a little something, maybe even invite somebody else. Okay, although that's a little bit hard because with academic office planning, we have to know ahead of time who to invite. But certainly, okay. So, give and take. You bring your interest, and I try to make this a rewarding learning experience for you guys. Okay? Good. Now, these are all excellent supplementary texts. I don't have, sometimes I have hard copies of this, but most of the time I have like a PDF, which is kind of like, it's not for general release in the wild, right? But let's say you want to read something in detail, okay? Come to me. Feel free to come to me. I might have like a excerpt or PDF or some sort of summary of it, synopsis of it somewhere I can share with you guys. Okay, so these are all very good. Now, more than that, some of these, I make a perfect link to them. I think they're all pretty current. I've been revising this syllabus for many years, so some of these are quite old, but still. Okay. And now, some of these things here, we'll talk about YouTube. Okay? So these are like channels that are very good. Okay? I try to link not to individual video, but maybe to a playlist. And these are all I do learn from YouTube. Okay? You just there's a lot of nonsense there, but there's a lot of sense there as well. Okay, and this is Timuchi. Gong Khan maybe come in, but I might, this guy is very good. He's it's interesting. When I was again, I told you I was FSVP doing data science at a commercial bank, and part of my give back, I guess, to the corporate, I give like a public talk for the whole bank, so that I don't just develop my own team, but I give knowledge to the entire bank. And he was actually an IT staff it wasn't my team, it was IT staff, and he listened to this thing about machine learning, and he had some prior interest. So he came to me, to my team actually afterwards, and said, oh, he wants to join the team. And now that I left the bank to do consultancy and ultimately get an academic position, he's sort of like is helping me with a lot of projects. Okay, so we do like a data science consultancy project. So I use him as my right-hand man. So basically, he's one down from me, and then from him, I use students for my project. Okay, now most of the bigger project, by big I mean take many months and a lot of money. I would probably use master level students from elsewhere in Chulalongkorn, but increasingly I try to use undergraduate. Okay, in fact, we just did a small little project that used 2 students from this class, not this class, but the class before this. So, so they got, I guess, call them pocket money because it's not that big of a project. In fact, when I was, I give a lot of public talk even when I was with the Bank of Thailand or Siam Commercial Bank. One of the highlight was that if I give a talk, and it's also like a recruiting tool. Okay, in fact, 2 of my team, okay, very strong, came from Chulalongkorn University, applied math. Okay, and it was because I was giving a talk at the math department and so forth. Okay, so that's enough of syllabus talk. Let's go to. By the way, I try to split the class sort of like in midway for you guys to have a break. Okay, I don't like people walking in and out during the talk, but during the break, then we all go together and so forth. Okay, if I carry it a little bit long, feel free to raise your hand so you don't have. Okay, right. Okay. So, what I've decided to do actually, okay, this is a game plan. Well, this is what's called interactive notebook. So it's a notebook. You can print it like a textbook. In fact, that's what I'm printing, right? And then there are codes. And this code, you can shift enter. What I'm going to do is actually take the codes out so that you have just all this English. You don't have to type again. Okay, I'll give it to you guys. And then as you build in, so it becomes your own notebook, so to speak. Does that make sense? So you can, so let's say this the beginning text. You can add, edit, or whatever to your to the text part, and then you can add the code, and then you say, oh, this is my example from this class, and so forth. Right? You get what I mean? Yeah. But right now you can't do anything. Just stare. Okay. In this case, in which case, okay, let's just stare. Now, we make it a little bit bigger then. Okay. Right. So this class, or this textbook, is actually written for this class. I've written a text, kind of like lecture notes before, but with this class, I thought it was about time to put everything together into one place. Okay. Data analytics. Let's look at the title. Interactive visualization, probabilistic modeling, and machine learning with Mathematica. So the subject is data analytics, the tools to learn and to use throughout your career is Wolfram Mathematica, which is a programming language and a platform. You see that it's more like an ecosystem as well. And I define data analytics as three skill set, put this way, okay? One is interactive visualization. Basically, it's saying that, analytics, tools to analyze data, all right? How do you do it? Well, you make a visualization tool. Sometime, if you can visualize the data and you can interactively adjust the dimension, the axis, the angle of looking at the data, you get the insight. Okay, I like to give an example. Well, one thing that almost doesn't require any kind of data manipulation whatsoever is world temperature, right? I don't know if you've seen this hockey stick graph, right? So, you know, temperature, industrial revolution, temperature, right? Or carbon dioxide or carbon concentration in the atmosphere. It's you know, it very fluctuates a lot, but the point is that's way back in the history, right? Millions of years. But since human became humans, and face it, we're not going to evolve physically much beyond this. So it's kind of stable, 400 parts per million, and you know. So just looking at the data, do you need to say anything? Do you need to do any kind of statistical tests or anything? It should convince you, right? Right? Things are looking good, and then industrial revolution, burning coal, and now fossil fuel and oil and all that, and we like this. Holy cow, right? It's that holy cow moment that you get just from looking at the picture. Now imagine that, let's say the picture doesn't exactly look like this because you were looking at a different angle, looking at different variable, okay? But by interactively playing with the visualization, you came onto this thing and voila, there's that hockey stick. So interactive visualization. Probabilistic modeling. Well, probabilistic modeling, in fact, is the whole of discipline. In fact, you can get the whole degree in statistics, right? With the Faculty of Commerce, I think, right? Business and Commerce. This whole, where you go in depth into statistics. Now, statistics, probability and statistics give insight into data, okay? The way I would say it is this. It's more powerful and less powerful. More powerful because for the problem that you should use traditional probability and statistics, it is more powerful than machine learning because it gives you details, it gives you convergence result, confidence boundary. It's powerful. It's you know, it gives you a whole thing. Okay, complete analysis. But it's less powerful in the sense that the problem has to satisfy a certain assumption. If the data satisfy this assumption, for example, the data is normally distributed, okay? Then none of this AI thing is going to give you any better conclusion. But if it doesn't, then you might use AI, machine learning, heuristic, all kind of stuff that we're going to learn with, okay? So probabilistic modeling is sort of like powerful when it applies. But increasingly, we're dealing with things where they don't apply. Okay? Finally, machine learning. Okay, finally, machine learning is a tool that's used to drive data analytics. Okay? Now, we are going to go into a bit more detail, but I want to imprint you with a picture. In fact, this picture I used a long time ago. And I just used this morning. Okay, this morning's class was Apply AI. I'm just giving a talk AI. That's the hockey stick I was talking about. Ah, there. That's the picture. That's a picture, right? There are 4 words that's being thrown about. One's AI. So thrown about in the sense that I adapt this from a lot of talk I give to commercial or public forum. There's AI, right? You hear that, a lot of that. ML, machine learning. Quantitative models, maybe you don't hear as much, but it's really in banking or it's a lot. Quantitative model, you hear well, maybe not so much anymore, but especially before 2008 crisis, you get a lot of very high-profile mathematicians who go and work for the financial firm and makes a lot of money and all kind of stuff, and they call themselves quants. That's quantitative model. Okay, so basically using high-power mathematics to solve financial problems that people who got this accounting background cannot. And then data analytics. Okay, and I'd like to take a moment to give you elaboration on this picture, because a lot of people, and again, this is the industry, they understand that AI is like a new tool that you apply to the problem. But I like to invert the story and say, actually, story starts with AI. AI is not new. Okay, AI is not new. So let's start with AI story. And in fact, in my lecture there, I mentioned this guy. Where am I? Right, this guy, right? Alan Turing. Okay. Now, a side story. Have you guys seen the movie, The Imitation Game? Have you seen that? No? Go find it. I don't care where. Find it. Okay. The whole movie has nothing to do with imitation game, but the imitation game has a lot to do with AI. The reason they call the movie Imitation Game because the protagonist, the hero, is based on the real person named Alan Turing. The movie is about what he did during World War II. Okay. But the imitation game is basically after World War II. It's basically the birth of AI, okay? But the movie has nothing to do with that. The movie just describes his life during the war time and then before he passed away. Anyway, so, right. The idea is this, simple. Back then, artificial intelligence doesn't mean intelligent. It just means human-like, okay? And during the war, again, he came up with a computer that cracked the Enigma code. It was basically computer. Once he created a computer that does this amazing mathematics, he asked himself, well, can a machine imitate human being? Hence artificial. So artificial resemblance of an intelligible answers, right? So if you ask, how are you today? Fine, thank you. That's not high science, it's just basic thing, right? But it's intelligible because it seems appropriate to say, fine, thank you, right? So AI in that sense doesn't mean intelligent answer. It just means answer that sounds like a human being. And because human beings are supposed to be intelligent, right? So artificial intelligence just means that computer that mimics human being. Mimics enough to imitate, to fool you into thinking that you're having a conversation with a human being. Now, in the 1950s, this was unheard of. First of all, computer, people didn't even know what it was, right? In fact, it didn't even use the same substrate or devices we do now with the integrated circuit. So, computer, can computer mimic human being? Okay, that's it. Well, in order to do that, because computer is just a computing substrate, you have to give it instruction. So what's the obvious thing to do? Well, the obvious thing to do is say, if input equal hello, output equal how are you, or if input equal how are you, output equal fine, thank you. If input equal what time is it, output equal to look at the clock, read the clock. You know what I mean, right? So you kind of like program I/O, input, output, response behavior. Well, quickly you're going to realize you're not going to be able to do that, right? Right? Because it's not like a toy that is programmed for only three words. You know, one of those pet toy that you can talk to, only answer three sentences. You can't have a conversation way beyond that, right? Can't generalize. So how do you program the knowledge of how to carry on conversation? So the idea was you can't program I/O. How about this? How about if you program an algorithm that reads a lot of I/O and then generalize from there. So the I/O becomes like a data point, and then you extrapolate. Now, extrapolate is a tricky thing, right? So you have a point here, point here, point here. You think the next point is there, right? But as you learn in high school mathematics, interpolation is much easier than extrapolation, correct? Right? Because point here, then change size here. But extrapolation, oh, that's a little bit tough. Well, but the concept is the same. The concept is, I can't program if X is this, Y is that. If X is this, is Y that. How about I program computer how to draw a line? That line takes a few points to start off, and once you got the line, you can interpolate and extrapolate, right? So the concept was to let the machine learn from data. So you're not programming I/O, you're programming a learning behavior to a machine. Hence, machine learning. Okay? Now, that machine learning basically is motivated by the need to create AI, or the wish to create AI. By the way, you see this throughout all kind of innovation you see in your undergraduate or Basai education. None of the game-changing innovation came from the motivation to make money. Zero. You give me anything, absolutely any kind of innovation that runs your modern life, and ask me which one start out by saying, how can I innovate something to make money? None. Okay. Well, at some point, yes, people will try to develop research and development that's motivated by a company to make money, but it always starts with curiosity. Okay. So this AI here, curiosity was, hey, we've got a machine that does amazing things during the World War. How can it mimic a 3-year-old, right? And now, of course, AI has done that. Okay, can mimic 3-year-old. Again, the key word is human-like, not intelligent. So you have a chatbot, as long as it's human-like, it could resemble conversation with a 2-year-old. You consider that intelligent. Okay, so AI motivates machine learning. Okay, fine. Now you will see, and this is sort of like the chapter 5, 6 of the book, and later half of the module. Once you got machine learning, this way of doing things, this way of programming the computer to build a model based on some data experience, goes way beyond the desire to build an AI. So now it becomes like, you know, I want to optimize a travel path from here to there, or logistic planning, all kind of stuff. So a whole bunch of machine learning algorithm has nothing to do with AI. Okay? But I would say that at least spiritually, machine learning was born out of the wish to program a computer to imitate humans. Okay? But now machine learning is, so it's not a subset. See a lot of YouTube try to say this is a subset of that, this is a subset of that. Not true, not true, not true. Okay? In some meaning, yes, machine learning is a subset of AI because you use machine learning to build an AI model, right? But then you also have machine learning, it's got nothing to do with AI, right? Or you can say that, oh, machine learning is a paradigm for programming, and some of the program that it applies to is AI. So AI is a subset of machine learning. Well, not necessarily, right? So sometimes YouTube gives you insight, but don't take it as a religion, as a dogma, sorry. Okay, so once you have this machine learning, to do this, then it kind of expands on what you had before, which is like linear regression. Think about it, yeah? You have linear regression, confidence interval. Now you have gazillion, well, not gazillion, 100 more models that does all kind of interesting things. Fitting, predicting, optimizing, pattern discovery, all kind of stuff. So all these are models. They are quantitative model in the sense that it works with some kind of computable quantities. Okay. Later on, you'll see what the large language model is, because language doesn't work with quantity, right? It works with language. But we'll see. That will come. Okay. So quantitative models is a whole world of thing. Now, in finance, quantitative finance, right? In biology, quantitative biology, right? So all kind of stuff that didn't have quant before. Physics, I believe, was always quantitative, right? So you don't have something like quantitative mathematics, okay? Although you can have symbolic and numerical. But things like quantitative engineering. Well, engineering is always quantitative. But now you have quantitative biology, right? Quantitative, maybe psychology even, all kind of stuff. Anyway, the thing is, once it's some kind of computable quantities, and we'll talk about how to get around that later, then it's quant model. And finance is, a lot of it is quantified, okay? So ML builds a lot of quantitative models. Now, so you can say that something like this, kind of like 1970s, 1980s, right? Now the world of data analytics, now data analysis has always been around, but as sort of like a huge discipline in and of itself, like an undergraduate in data science or something like that. This only came in the last 20, 30 years, simply because of the quantity. Because so much data, right? Before that, you didn't. Before that, how are you good? How are you expert at something? How are you expert at something? Or how do you do a research? You build a hypothesis, right? Some kind of mathematical equation with some parameter. Then and only then, you try to find the data that helps you calibrate the parameters. In fact, I remember, because I started my career with the Bank of Thailand, and I was always invited to teach MBAs. Virtually 90% of the MBA thesis is all about something like consumer attitude or preference or taste or something like that. And how do they get that data? They give paper questionnaire and they go stand in front of Siam Square or something, have somebody fill up. So that's how data, it came later. So you have this theory about what motivates a consumer. Consumer likes red if it's a girl, blue if it's a boy. You want to see if it's true, then you go and ask questionnaire. And then you get like 200 questionnaire fill, and then you put in this contingency table, chi-square, and all kind of stuff, and that's your master thesis. Basically, 20, 30 years ago, when MBA students were doing just that. Okay. Now, would you ever have a project where you just go and take a literal survey from 200 pieces of paper? It's very rare. Okay. Sometimes you do. Special case, very, like a product clinic where you want to sort of like really get an intimate feedback from your client cohort. But increasingly rare. So now, again, it's almost like that. This is no coincidence that coincide with what I told you earlier about the flipping of model building from model, mathematics, parameter, data into data first and then back to business model. Well, it's because there's a lot of data. Okay? There's a lot of data because your lives are digitized. Right? So in your parents' day, if they want to say, where was I last week? Unless they kept a daily diary, it's gone. Okay? Right? Whereas you can, well, not this one, but a digital watch, right? You can have and say, where was I last Tuesday? How many steps did I take? Right? Oh, on that last Thursday, I made 117 meter in elevation gain. You didn't want to know that. You didn't even care. Okay? So your life is digitized. Okay? That's why data overwhelm. Well, QM, quantitative model, drives all of this. Because before you can analyze, you need a model to analyze. Okay? Doesn't matter what. You need a model. There's a mathematics. So quantitative model is a mathematical model. Okay? You can have physical model. You can have that kind of stuff. But mathematical model means you represent the entities and behavior with numerical attribute, and you represent interaction with functions. Okay? So ultimately, you turn things into variable, and you turn action, interaction, relationship, all kind of things into function. And then you run that function on that variable with the right parameter, you get some output variable, and that output variable gives you something. Okay? Either you get insight from the output itself, or the nature of the function itself gives you the insight. Oh, whenever I increase this thing increased linearly. That's an insight. Whenever I increase this, nothing happened. But if I increase this and that, the third variable increased exponentially. E to the x times y, right? So x alone does nothing. Y alone, it's kind of like that. That's something, not nothing. Right. So maybe not e to the xy, but you have to have some kind of, no way. I'm just giving an example. Right. So now here's a fun thing. I wrote this. In fact, I used this. This is very old picture. Okay, you'll notice it's actually captured as a picture. Long time ago. And here I wrote the word data analytics validates AI. In that sense, in what sense? In the sense that it validates the whole thing to begin with, that you can do a lot of stuff, and the journey begins with AI. Okay, it validates this human intellectual undertaking. But you know what? Since large language model came on scene, this word validates means a whole lot more. Because now you have generative AI that can give you answer that sounds good, but is not necessarily valid or rooted in ground truth. So now you need the data analytics to actually come around and tame the behavior of AI. You have to use data to validate whether or not the AI response, generative AI in particular, is rooted in ground truth. So this word is a little bit more powerful than when I initially wrote it. Anyway, so let's get back to our thing. Right. This book grew out of, okay, I mentioned this class. Now, it's a kind of like formatting instruction. Okay, now let's go to by the way, any of you have done programming with maybe Python? You have, right? What do you use for your IDE? Jupyter Notebook? No, what do you write it in? The editor? I know most students don't use this anymore. It's too big. But you probably write it in like a Jupyter Notebook, right? You guys, you notice how the Jupyter Notebook has little cell, right? You know where they got that idea from? This. So Jupyter Notebook was written to imitate Mathematica Notebook. So that's why Mathematica Notebook does this obviously, right? So let's do some of this. Now, obviously, this is only text cell. Chapter 1 is only text, but as you go down the line, then you start have computation cell. Okay, right. So with a little bit of so that's why some of you will say, "Hey, I've seen this kind of style of writing before." Well, it's a Jupyter Notebook. Takes an inspiration, but they don't mind. Computer scientists are very generous people. Okay, so what's data analytics? What's data? What's analytics? Okay, right. Don't have to write this down because again, I'll probably give you this text. refer to suite of mathematical or probabilistic, okay, quantitative, statistical, okay, computational, algorithmic, informative and interactive. These are all pair. Human or artificial intelligence tools. Okay, so you take all the quantifier out, it's a suite of tools used to analyze data so that you can extract insight, okay, involve some kind of interpolation, extrapolation. Okay. Right? Fine. But what do you mean by data? Now, this, by the way, is something that I like to do, and I would like to see all courses in Basai do, which actually, I call it make difficult thing easy and make easy thing difficult. Make difficult thing easy because some things are technically complex, so you need to know how it works, but you may not need to know nitty-gritty, so you know, I can sort of like skip over some details so you get an intuition of how things work, like how does ChatGPT work intuitively, right? Make easy thing difficult means the concept you take for granted, you think you know, okay? Let's explore it as if it's something difficult to understand. Let's analyze it deeply, okay? Same thing, what's data? Anybody? Okay, most of you say data, is something you load to do things, right? Okay, what makes things data? Okay, you take my height, you take my weight, you take my blood pressure, is that data? No. Well, it is now, but no, not really. Okay, I'll give you the answer. Data, okay, henceforth, digitally store, capture, or manage, just so that, you know, we don't deal with data in papers, okay? It's an accumulation. You have to accumulate. Or collection or compilation of measurements or records, okay? So, again, don't take anything for granted. Every single word counts. I spend a lot more time, you know, cleaning up this definition than a lot of things I do, okay? So it's a measurements and records, okay? First of all, what's the difference between measurement and records? Come on. Okay, my height is a record. It is also a measurement. My question, when, where, how is my height a record? When, where, how is my height a measurement? Okay, I'll just move along, okay? Again, I want to spur your thought. I don't want to just, you know, be a coder, learn how to do things. I want you to think. Well, it's a record because it literally pins down my height at a given day, right? So obviously, it has a time element to it. Well, if you record my height, well, certainly time dimension matters a lot. But if I'm taking all the heights, the record then doesn't, I'm not so worried about the time, but I'm worried about an average height of a Thai student or something like that, right? In which case, that record pertains to a member of a population. Okay, anyway. Why is it a measurement? Well, what's a number? A number does two things, count or measure. How many kids are there? How many students are there? 1, 2, 3, 4. Okay. Do you do that with my height? You don't. You don't go 1 centimeter, okay, you're taller than that, 2 centimeter, and keeps counting until 169 or something like that, right? You don't count my centimeter because the counting is done on a stick, right? So you put my head next to a scale. The measurement is vis-a-vis scale. Vis-a-vis a scale that has the incremental counting. Okay, that's why you can have 169 centimeter 0.5. Okay, So become like, real number, whatever. Again, I want you to just think. Now, not all of this is going to be like some question I'm going to ask in an exam or something. It's silly. But think, okay? Don't just be here to learn how. Think. Okay? It is pertaining to a particular sample of entities. This is very important. Data is not about everyone. Never is. Data is always about a sample. But that sample is drawn by some larger concept. If I take your height, you belong to a larger concept of freshman Chulalongkorn University. You belong to a larger concept of human beings. You belong to a larger concept of mammals. Right? Cellular, multicellular organism, I don't know. Right? That population or phenomenon, so we talk about financial time series, you don't just take the height of a human being, you take the price of a stock. Okay? So phenomenon, temperature, phenomenon, okay? Not entities per se. Okay? Or events from underlying population to phenomenon. So entities, event, population, phenomenon. But it's from there that you want to model, you want to control the larger concept. So if I take your height, okay? If I take your height so that I can buy you a suit, that's not data. That literally is information because that's all I need. I'm going to buy you a suit. I need to know how tall you are. That's not data. I don't need to gather data about my children so I can buy their school uniform. That's information. My daughter is this tall, my son is this tall, I buy a shirt, I buy a suit. But if I take your height, take your waist measurement, and that becomes my basis so that when I want to set up a t-shirt shop, so I can tell to Chulalongkorn University students, I don't make them too small, I don't make them too fat. Right? Because you are Chulalongkorn University student, right? I'm going to make Chulalongkorn University t-shirt to sell. So presumably, they're not much bigger than you, they're not much smaller than you. So, but maybe I'll do even fancier. I say, okay, I'll do a clustering. Oh, maybe there are only 2 sizes. So I only need to make 2 sizes, medium and large. Right? Because I'm taking measurement from you, but I'm not interested in you. I'm always interested in something that you represent. So it's particular measurement, but it's not the particular sample that I care about. Okay? Now, I'll probably sell my t-shirt to you, but certainly I'm trying to sell my t-shirt to 1,000 Chulalongkorn University. Okay? You are just my sample. So you want to sort of model or control, optimize. So each one is just a data point. Yes, obviously, the whole thing is a data set. Okay. So this is something. So go back and read this. I'm going to skip a lot of this. All right. Let's see if there's something else I need. Yes. Come. I know. Good luck and have fun with your volunteer. Right. Certain sample reference population. Okay, read that on your own into the future. And again, a population doesn't necessarily mean some other entities. It could be you in the future, for example, right? So if I take a sample of your blood, okay, today and yesterday, it gives me idea about what medicine to give because tomorrow you're going to have that kind of blood, that sort of thing. Right. Now we talk about digital data because Okay. What about analytics? And we talked about this already. That is about analysis, right? And basically, I kind of group them into 3 skill sets, so to speak. And that reflects in the chapter breakdown, okay? Interactive visualization is one thing. Probabilistic modeling, so statistics fall under this, right? Side note, why is it called Department of Statistics? Why isn't it called Department of Probability? Well, actually, because in application, it's in a way, it's already giving a predominance to the data aspect, because statistic, even just gathering the data, is already statistics, right? So statistics to summarize data before any kind of analysis. But anyway, in terms of application, you always end up with statistical inference. Okay, so probability model is how you start, but you end up with statistical statement, statistical inference. So it's Department of Statistics, but as a tool building exercise, I focus on quantitative model building, and I say, what kind of quantitative model? Probabilistic model. In which case, statistic becomes a way of calibrating. Right? It's like setting, to draw a straight line, you need to intercept and the slope, right? Modeling does that. Statistics tell you exactly what numerical value of the intercept, what exact numerical value of the slope, okay? So when I focus on model building, I focus on the probabilistic modeling, but statistics would be, okay? And finally, machine learning. Okay, so why data analysis? Why now? Obviously, because data is everywhere, big data and so forth. And idea here is, this book try to. It's a bit like the learning outcome of this class. It's not teaching you the nitty-gritty, nor top-level eye level view, but it's sort of like giving you the empathy, the feeling, okay, this is what the data scientist would have to go through. So it's the idea of taking you through the workflow or the pipeline. The favorite word of us data scientists is a pipeline. I have this thing and this thing and this thing, and it's a pipeline. And data comes in the beginning and insight come at the end or something like that. So it's a pipeline with processing. So I don't know why they call it pipeline. They should call it like a refinery line. Like when you take a crude oil, right? It's a pipe, but what you start out with is crude oil. What you end up with is gasoline. So it's not just a pipe. So pipeline is a good word, and I like to use it, but there's more to it than that. There's a pipeline with processing along the line. When, everywhere. So this is a very nice kind of like schematic I want you to keep in mind. So data plus analytics, right? That gives you observation, gives you some kind of conclusion that you can generalize from. Now, this on its own, unless you have kind of context, like I'm working on finance, I'm working on logistics, I'm working on some kind of marketing, okay? Then you add that. That becomes your information. And that information then, okay, if you just have information, but you don't have a marketing specialist, or you don't have kind of marketing insight or kind of paradigm to it, then yes, it is an insight. But certainly, if you have somebody on your team who study marketing, okay, and has a perspective that, marketing has this 4P, and there's this segmentation theory, and there's this idea that if you can segment them, then blah, blah, blah. Now, the result that comes from the insight could be, what I say before? The information cluster. Let's say the information is that Chulalongkorn University comes in 3 clusters of size, right? It's only with marketing paradigm that say, hey, one size doesn't fit all doesn't work, okay? Nowadays, everybody wants to fit their own size, so fit T-shirt to size, okay? But how many size? It doesn't know. It just say that sell T-shirt that fits, okay? You can't just have one size fit all. It doesn't work. Sell T-shirt that fits. So T-shirts are not like motorcycle. People make motorcycle, one model, one size, right? You don't have Kawasaki Ninja 500 small, medium, and large, do you? Right? If you so they make some kind of minimum. If you large, it feels cramped. If you small, it feels like a stretchy, right? But you never have small, medium, large motorcycle. Just have different model. Well, T-shirts are different, right? So marketing say, okay, fine, people have different size, but we're selling motorcycle, we just make one size, we don't care. Who knows, in the future, marketing may say that, hey, you know, millennials or generation after that are so picky, even their motorcycle has to have different size. Who knows? Okay, so you have that paradigm that's sort of like high level industry, that becomes the insight. Then of course, that insight goes with context. Like, would it cost too much to make multiple sizes in motorcycle? Would it cost too much to make multiple sizes in t-shirt? But with t-shirts, not so difficult, is it? Right? So there you go, multiple size in t-shirt. Then you make the decision. Okay. So this is kind of how the professionals do it, so to speak. Now, they don't sort of linearize it necessarily, but I want you to delineate, right? So something that's strictly output of a computer, right, that you can generalize, doesn't necessarily go to decision, right? So our data analytics kind of like stops here. Now, there are computer algorithm and decision model that helps you further down the line, like decision models, but that's not what we're talking about, okay? So they're actually other analytics, like decision model or something like that. Operations research, I mentioned to you. Well, that was my master. That's also about optimizing decision. So it literally it's optimizing this, okay? But not this class. This class kind of like delivers you here, okay? If you can get there, you're already good. Okay, that's already good, okay? But like I said, my master takes you to decision in some case. Some of this, okay. Right. Again, how you doing? Do you want a break? Okay, fine. Let's take a break. 5 minutes. Okay, we'll come to data analytics a little bit more, and then we're doing good.